Hello from Romania. Uh, I I am in the process of building this. A couple of words before I start anything. I want to present the process of everything that I did. This is the history, very fast, a couple of days ago actually, but it took me some brain power and some serious effort to make it, because it was not easy. It was definitely not easy. It was quite hard, not extremely hard, but quite hard, hardcore. What you are seeing here, here I was preparing the here I was preparing the transistors that I wanted to use, but I didn't use all these guys because they were extremely weak. They look like a power transistor, but they were at 300 milliamps, and nah. And then I got lucky. I find the BD 441s that actually saved my entire project. And what I want to show you here is the way I catch these radiators, these aluminum heat sinks. So I literally sew them with sewing wire string, with sewing string. Also take a little time of reading this warning and everything here. This is a normal cardboard that I took from a plier or wire cutting thing. But the warning is very serious about my circuit here as well. So I shot two rabbits in one shot, with the one shot. This is the layout that I actually use is a scale 1 by 1, so exactly the same scale as on the board here. I actually measured first. I did this drawing here to figure out the placement and everything. I design it. This is the design of the circuit, and then I measured the distance from this point to that point, pretty much. And then I didn't made another circuit, but only a single line that was showing me the total length of the all 8 transistors. And yeah, I chose the cardboard, and was quite thick cardboard, and nicely colored. I don't have them sorted by color. This was just a random choosing of this cardboard. I didn't really, but I chose it because it was thick enough. And here is the progress. Like I said, the evolution of the and building and the history of the thing. I kind of started with the tail of the circuit and going back to the head of the circuit in the building process. So now I'm adding the NOT gate here, 7404. Actually, it says there not gate, and also the signs. And look on the wiring, a lot of wiring, and it took me hours to calculate the length that I required, not to cut them too much length, than to waste material. And yeah, these are scrapped resistors, all of them. But the transistors, all of them are brand new. And these are the new 441s, I believe. There, yeah, you can see it. You can barely see it. Let's see if now. But here you can see a 4. BD, this is BD 441. These guys are old stock, but brand new. I have them for more than 10 years laying in my arsenal of transistors there. All of them are NPN transistors. I go too far. And this is a test that I did. Look how many wires I have to connect on everything. So let me make a traveling an itinerary for you. This wire was the minus, the ground, the white wire. The yellow was the positive wire that is connected there. Also 4 wires that were connected to these diodes here, and from all these pins from here. This black wire here, this another black wire, this yellow wire here, and the red wire, this long, very long ones. And here for each coil of the motor, other jumpers, other wires, and also the power of the motor, another 2 wires. Holy testing worked, but it worked. Here this is not connected yet. I believe this. No. I didn't make a picture with everything connected. Unfortunately, I only took a picture for the wiring. These are the diodes here that I was preparing. Like I said before, I started with the end of the circuit. Like you see, let me actually. So this is the circuit that you can actually see it here. Here is this circuit here, and and this is the NOT gate. That this chip here is representing that gate. This gate as well, this gate as well, and another one here that is not visible. So 4 NOT gates are in one chip that is containing 6, I think, gates, N gates. This is the current development. This is the right now, how it's looking right now, and it is connected to this on the breadboard. For the logic, and only the negative plus and positive plus 5 volts. That's it. And no, and the power for the wires. All these jumpers, I right now I needed to add to the circuit, to the breadboard. Only 5 wires, pretty much. But this motor are already motor wires that are connected, and yeah, it's making life a lot more easier. And this is another view of the current circuit that I'm building right now. Hope I got too fast. And this is a close-up, and here is another close-up. Yep. Let me actually turn around a little bit. This is the proper way we should look at it. So this is 1 kilo, and these are the LEDs, the blue LEDs, and these are the diodes, S524. they are called. Schottky diodes, I think, SMDs, Schottky diodes. But I want to tell you about these motherfuckers, these LEDs. These LEDs are very extremely bad. In what sense are bad? I mean, they give, let me like this. So they give very good illumination. They are very good from an electrical point of view as a LED. I really like them as LEDs, but I don't like them as the pads they have. I keep like 2 seconds, no 3 seconds, maybe 3 seconds. I keep my iron on the pad to solder, and the LED got destroyed. The plastic melted on the pad, the soldering pad. Flew away. So not putting the soldering iron directly on the metal pad that is having underneath it, it doesn't have like an ear like that. It's all like underneath, and it's extremely hard to solder. It's stupid. It's stupid. No, I don't like it. I don't like it at all. And the page when I buy the LEDs from, of course, from eBay, they showed me a totally different model. It's the same size. It's 1206. So let me type it for you. So 1206. Like that. This is the come on. This is the model of the LED, and also its dimensions. It means 12. It means 1.2 millimeters, and 06 is less than 1 millimeter, almost half of a millimeter, which is the width. And this is 12 here, and this is 06 here, and also here 06. So these are this is the size, but also the part number as well. So I received the correct part number. No commenting about it. It's good. They are blue LEDs like I ordered, no problem. But the LED itself is having like this, the pads underneath. Actually, not that much here on the side. Most of the pad is underneath, and is incredible. I discovered the way of soldering by heating up. As you can see here, I'm soldering directly to the resistor pad or terminal. And I discovered the only way I can solder these guys, these motherfuckers, is by heating up the metal, this metal here, by putting my iron here, heating it up, prepared with solder, of course. And when the solder is getting liquid, the pin of the LED is wet of solder and is making contact, but it's not really my way of doing it. It's good, but not good enough. And I don't like them. I like them from the fact that they are very good LEDs, actually. The light is very strong, very bright. I love them from this point of view, but the mechanical point of view is they are horrible, I tell you. So this is it about the LEDs. I managed to make them, to solder them, but nah. I wanted to specify this little detail because they are cool LEDs as if you after you solder them, but before and while you are solder them, it's a pain. It's a pain in the butt, and it's not good. It's not good at all. Thank you very much. This is it for this part. Hello from Romania. I am in the process of building this stepper motor controller board. And originally I made it on the breadboard here. As you can see, there are some elements missing there because I actually took them from there and repurposed them here exactly as it was on the breadboard. Now it's here. Some of them, not all of them. And it's let's say it's half. No, it's not half of the circuit. It's more than half. Here is the circuit on the, if I can get rid of this. So it's from, where is my knife? Here. 1 second. So it's from, where are you? I believe from here. Yeah. So it's from here all the way, all this way, all this stuff from here on this board. And on the breadboard is this lot here, from here to here. The 555 brain. This is the brain of the circuit. Is the pulse frequency generator. Actually, I wrote it here. Write it here. And this is the voltage regulator here. And pretty much they are this part here. This part from here to here is that is the left. Here is the I didn't manage to make it yet. I managed to only to make the component layout pretty much. And I prepared the components. Actually, this potentiometer was broken, and I put a little piece of metal beneath it because the pressure was not enough and it wasn't stepping right on the track. So I opened it. I put a piece of metal beneath as a distancer, and that distancer made a little bit of pressure. And there are some spring elements there, and now it's absolutely perfect. I made a WAGO. I modified the WAGO connector. This connector was, you inserted a wire through here and another wire through this one, and when you click these things, we're connecting all these wires, these two holes and wires together, pretty much shorting them. But I cut the metal. I open it. I cut the metal, and I separate the connections. This thing is the yellow wire, and this guy is the blue wire, and it's very practical. I was thinking to use it instead of this guy. Unfortunately, I have only one connector like this, but this I made it later. This I made it faster and easier than this. This it took me some trial and errors to figure out how to open it and then how to solder it, because it's having some elements there that are not solderable for some reason. They cannot catch the solder, but only one thing managed to catch it, and then to cut that piece of metal that was bending, and it was hard to catch here in my vise. It was a bit tricky, but I managed to make it work, and it is working absolutely as before. The exception now is it is separated, and the smart guys from Wago, well, I outsmarted them because they don't have such an element, which is, in my opinion, is extremely practical like this. Way more practical than shorting the two wires. Nah. But this is my opinion. All right, so what I did here, this is a part of the circuit. This is a test wiring that are still connected to the breadboard, because like I said already, part of the circuit is not done yet. It's not finished yet. I made this connector here with separate wires for each motor, and the motor is running right now. And if I am, let me encadrate like this, and if I'm doing like this, increasing the speed, also the motor speed is increasing, and it's functioning absolutely fine, absolutely okay, as originally designed. And the difference from this motor driver, oh, by the way, 5 volts at 600 milliamps, if the speed is low, but if the speed is high, it's going down at 400, like this, to 250 milliamps. 250 milliamps there, and it's stabilized right now, and it's exactly as I remembered as well. So pretty cool. This is the maximum speed from this board here, and yeah, and I can switch these connectors here until I can get the wiring, the proper wiring from the one. I have different wiring for this and different wiring for that, and I'm not sure if I will add for 5. It should work for 5 wires motors. We'll see. But for now, for 4 wires motors, 2 phases, 4 wires motors. By the way, it's absolutely okay. This board is absolutely okay, and it's doing a great job. And the difference from the other boards that are out there on the internet is that this board I actually modified and put here a note. So for Q1, Q3, as you see here, for Q1, Q3, Q5, and Q7. I use BD441, which are very powerful transistor, 4 amps and 40 watts, or 35 watts or something. If I'm not confusing it with another one, which I put my eyes on it, 681 I think it is. Also, and these are the old ones that I previously used, BD139 on Q2 here, the lower side pretty much. The lower side are Q2, Q4, Q6, and Q8. This is Q2, Q4, Q6, and Q8. So this is the lower side for BD139, which is 1.5 amps, and I forget how many watts. And these are very, very powerful, and the difference is colossal. The difference, this made all the difference. This BD441 and the others that will come will make even greater difference from how it was only with BD139. When it was with BD139, it was heating up, especially the top transistors. So by replacing them with these models of transistors, that heating up disappeared. They don't need this full radiators. They don't really need these radiators, but because this is a more of a testing board here, what I have, probably I will higher the voltage and also the amperage probably. But the amperage is pretty limited by the circuit itself somehow. I don't know, but it is not letting all the amperage surging through the transistors. It is limited pretty good actually, and is proportional with the voltage. So if I'm increasing the voltage, also the amperage is increasing. If I'm lowering the voltage, also the amperage is lowering as well. So pretty much the power of the entire circuit, including the motor, is proportional with lifting up the voltage or the amperage pretty much. So they are proportional, which is good. But it is limiting by themselves, by the components. The components are limiting the amperage. The MOSFET version, I don't have it, but I tried it here on the breadboard. Is letting pass like a lot of amperage, like 2 amps I got at some point, probably for that one and this one, at a small voltage at 4 volts or something, and they heat up, of course, but they did do the job. I didn't raise it more than that. They were starting to getting extremely hot. But these guys that I have here are all NPNs. I forgot to mention, but everything you see here is NPN based, all NPNs, not PNPs like the usual internet circuits are telling you. So this is kind of my design, well, not my design, but my insistence. I insisted to make it from this, partly because I have a lot of NPN transistors in my arsenal, so I wanted to use them as literally as switches. I don't really need them for frequency or whatever, or gain I don't work with gains from the transistors, but here in this case, they are literally switches and nothing more. And doesn't matter what you are using. In my case, I used all NPNs, and they are driving pretty good current, and I believe it's good enough, and especially for testing, like I said. So this is the progress so far. And I will have to finish it. I still have a lot of stuff to make. I prepared here everything, and see you later, alligator. I don't know how I will make that. That is the voltage regulator that I put a large heatsink because it was getting extremely hot. Probably from the previous experimentation that I did, not from this one. Definitely not from this one, but it is getting hot, but not very, very hot. The previous one was getting extremely hot with the MOSFETs. But now only one heatsink like this is good enough for him. And yeah, pretty much this is it. Thank you very much. I hope you like it. Leave a like, and see you later, alligator. Bye bye.